All right, welcome again to part 2 of the introduction or the fundamentals of precalculus. So we looked at the real numbers last time and some of the important aspects like the properties, their properties of real numbers. We looked at their addition and subtraction, things like commutative, distributive, laws and such. We looked at multiplication and division, okay, cross multiplication and things like that. Then we looked at the real line, okay, its application. We also looked at the importance of the real line. Now we look at the sets and intervals, then we look at the absolute value and distance. So when it comes to sets, okay, we have to know certain definitions. And so what is a set? A set is a collection of objects, and these objects are known as the elements. And we can, for example, say set A is 1, 2, 3, 4 in this case, and so on and so forth. And so 1 may belong to A, whereas 0 doesn't belong to A. So we need to know these symbols. Then A, this is another notation. We can say that X is such that X is a natural number that is greater than 0. Or we can say X is such that X is a natural number. So then we're talking about the whole set. We can still look at other aspects to this, which is representation of sets. And now when we talk about representation, it's best to understand the main groups of real numbers. So we have whole numbers. These start from 0 and onwards. Natural numbers, this is a set of numbers starting from 1 onwards. These are the ones that we use for day-to-day counting. Notice the difference between whole numbers and natural numbers. It's the 1 and 0. Then the integers. So these are negatives, they've got a 0, and then they've got natural numbers. Then we have the rational numbers. These are represented as fractions or ratios. So you have P over Q, where P and Q belong to a set of integers, and then Q is such that it cannot be equal to 0. Okay. And then we have the real number set, which is everything rational and irrational. Then we have complex numbers. These can be represented by x plus y, I. Then xy are real numbers, and then I is imaginary. Okay. So that is something to remember. Then we can do operations on sets. And these operations, the main ones are union and intersection. So union, this means that you put everything from all the sets involved together. So it's everything. Okay, then intersection, you just get the common elements from all the sets that are involved. And the representation is a symbol like a U for union and a symbol like an N for intersection, but obviously there are other operations involved. Okay, then we have the example here that will help us to see what union and intersection are. So we have set A with those members, we have section B with our members there, then we have section C, 1, 6, 7, and 8. Okay, so the best is to also do graphics. Okay, not just to use our minds, but also to use our eyes. Okay, so we do a graphic. So best is to start from the middle. What is common to everything here? Okay, sorry, I forgot a 6 here. So a 6 is common in all the sets. That's the one we put in the middle. Then we go and look at maybe A and B. What's common between A and B? We find that it's 4, 5, 4, 5. So we put them in the middle there. Okay. Then we look at maybe B and C. What's common to B and C? We see that it's 7. So 7, we put it there. We also look at what's common to A and C. Okay, we see that it's 1, so we put it in the middle there. Then what remains for C is 8. What remains for A is 2 and 3. So A intersection B intersection C is 6. Then A intersection B will be 4, 5, 6. A union B union C, it'll be all the elements put together, which is 1 to 8. Okay, so this one gives us all the members. Then now we can go on and look at the notations. Okay, so or the intervals. So the notation for intervals. So AB, remember these brackets, when you have them like the square brackets, it means that you're including the points themselves. If it's the usual brackets, then it means that it's actually closed. So you're not including the start points. So here, the most important thing to understand is just the shape of the brackets that you use. So remember, when it's a square bracket, it means that the start point and the end point are included. Okay, or the side where the bracket is actually included. Okay, so then the absolute value, okay, this is what we use for magnitude, because magnitude cannot be negative, so the distance cannot be negative. So it's 2 straight lines like that represents the magnitude or the distance. Okay, so it's from one point to the other. So this is also something that we need to be able to understand. Okay, distance is always positive. So for example, if we put A magnitudes there, it will always be greater or equal to 0. So we can represent the negative side, the positive side, as we've put there. Then the most important properties, A will be greater than 0. If we put it inside the magnitude signs there, if we put AB, means that the product of those two still give us a positive value. Okay, can't get a negative from there. So in summary, we looked at the real numbers, okay, their properties. Then we went on and looked at the sets and intervals. Here we gave an example, showed a few groups, whole numbers, natural numbers, and so on. Then we looked at the union and intersection sets. We also went on and did an example of the same. And then we also looked at the intervals, their notation. And then we looked at the absolute value, just briefly, just reminders of our algebra. Okay, so we looked at all these various aspects. So thank you very much for following. We'll continue next time. Thank you.